let's begin. We did a few examples last time. We are going to do more examples. So last time we did some simplification examples. Right now I want to do some solve for x examples. So back examples. Solve for x. Solve for x. You are going to solve for x. Tell me how to solve for x. First one. We have ln of x equals, this is 9. Yeah, what happens? How do you solve for that? What is x? Okay, how do you know?
ln basically equals e, so like...
Well, the base is e, yeah, so there's an invisible e here, so what?
I forgot what's the exponential, I forgot what it's called, but like...
There's a rule that says if you have logs of the base a of b equals c, then it means a to the c equals b.
Yeah.
That's the definition of the logarithm. And so pretty much that's exactly what you have here. You can immediately just jump to e raised to the 9th due to x. So just e to the 9th is x. Another way you can look at this. So this is strictly by the definition. That's what a log means. When I say ln of x equals 9, it's exactly the same as me telling you e to the 9 equals x. Another way to look at this, remember that we discovered last time that logs and exponentials in the same base are inverses of each other, which means you can use one to cancel the other. So here, if I have a log, and notice that the x that I want to solve for is stuck inside of a log, how do I break the x out? Well, I do the inverse operation of a logarithm, which is to exponentiate. So one way you can think of this is if I have ln of x equals 9, what you can do is you can use the exponential to cancel the logarithm. You can plug both sides into the power of e. And what's going to happen here, there's a rule that says e to the ln of anything is just a thing, so they actually cancel each other. And so that would leave us with x on this side. And over here, I just have e to the 9th. And informally, we might say things like, what I just did, we might describe it as I just e both sides. It does not make any sense grammatically or actually mathematically, but whenever I say, oh, just e both sides, I'm talking about doing this kind of thing. Raise both sides to the e, put both sides in the power of e, and so the e both sides. That's how we say it. But yeah, logs and exponentials are inverses of each other. So if I want to get rid of a log, I can use an exponential. Just make sure it's the same base. So if this was log to the base 2, I would raise both sides to base 2. That will kill the log to the base 2 and allow me to break out anything that's trapped inside the logarithm. I can use an exponential to get it out. It also goes straight from definition rule 1 from last time. So yeah, that one was just 2 ways to think about that one, but it's a one-liner, really. About B. How about solve for X?
Basically, put b with 10, and then maybe equals 3x minus 2, so e to the 10th power equals 3x minus 2. That's right.
Why would you say e to the 10th power equals 3x minus 2?
Because then we just do a, when we treat it the same way for what we did for a.
Sure, but in A, what rule did we use? This happens if A raised to the c equals b. Yes, on this one, it's like you have this side. You probably want to go to that side. So what does that mean? We can go back to ln. Now, the base is e, so what does this actually mean? This means 3x minus 2 is equal to log to the base e of 10. So this is by rule 1. There's another way you can think about how to get to the step. Another way. Again, using the fact that exponentials and logarithms are inverses of each other, you can say log both sides. Right? And that basically just means plug both sides into a logarithm of the same base. So what I would do is, because the base is e, I'm going to use log to the base e, and I'm going to log both sides. So I'm going to plug in both sides into ln. What is going to happen is that there's a rule here, I believe it was rule 8 or 9, one of those two, that says those two will actually kill each other. And then I would end up with the 3x minus 2 equals ln 10, which is what we ended up with here. So you have a couple ways to think about this. There's an exponential. I don't want the exponential there because the thing I want is in the power of the exponential. How do I get rid of the exponential? With a logarithm, of course. Same way. How do I get rid of addition? Subtraction. How do I get rid of multiplication? Division. How do I get rid of exponentiation? Logarithm. How do I get rid of a logarithm? Exponentiate. Right? These guys are inverses. You want to think of them as inverse operations. You can use logs to kill exponentials. You can use exponentials to kill logs. So if you see something like this, there's an exponential that you want to get rid of, you log both sides. So that means you plug both sides into a logarithm, and by choosing the appropriate base of the logarithm, it will allow you to cancel the base of the exponential. So here, the exponential was base e, so I log both sides to the base e. I will end up here. How do I solve for x?
Add 2 on both sides and divide by 3.
Yes, regular algebra at this point, right? Add 2 to both sides, 2 plus ln 10, and then divide both sides by 3. warning here. There is a potential risk for mistake that some people make here. Happens every so often, so I just want to make sure that you know that this can't happen. The following is incorrect. So sometimes you might have like the 3x minus 2 equals ln 10, and every now and then, let's see, so we'll add the 2 to both sides, but here's what happens. They see the 10 plus the 2 beside each other, and what do they decide to do? They decided to add the 10 and the 2. This is very wrong. The 10 is inside of the ln, right? The 10 is being operated on by the ln. The 10 and the 2 are not like terms. You cannot combine them. You can only combine like terms. Similarly, let's say you actually did not make that mistake, and you get ln of 10 plus 2, but you know that they're to be kept separate. Another thing that I see students do sometimes is that when they divide by 3, they divide by 3 inside the ln. And that is also wrong for the same reason, right? You're multiplying by a 1/3. You cannot bring it inside. The most you can do is move it as a power up. You can write as ln of 10 to the 1/3. I don't know why you would do that, but just make sure that you cannot go inside the ln. I should write that down. Pretty much you want to think of it, the only thing that can get inside of an ln is going to be an exponential. It's actually going to kill the ln. The ln is going to not be there afterwards. Don't think it can take something not from the inside or outside and multiply it through the ln. It doesn't work. So here, this is our answer. Notice that the 2 is separate from the ln 10, and the 3 is dividing the entire ln of 10. It's not dividing the 10. And that would be the answer. Don't mess with the inside the ln. It's kind of like, we're going to talk about trig functions, but it's kind of like a trig function. How you can't mess with the angle of sine from something outside of it. So make sure you know that. Potential for mistake there. Let's do C, which is somewhat similar. Okay, what do we do now?
Divide by 5 on both sides.
First move the 5, divide by 5, yes.
And then just do the other column, which is ln, substitute.
Log both sides. Log kills the exponential here, that's 3x. So this gives me ln of 3 over 5. Now the 3 over 5 is inside the ln here because I actually did the division before I did the log. And so now I can just solve for x by dividing both sides by 3. The 3 does not mess with the 3/5, so I don't cancel the 3's or anything like that. That is the answer. I'll leave it like that. That's what my x has to be. I'm going to solve that one. Log both sides. What base do you want to use? I log to the base 2 of both sides. Those would cancel. Here I get x squared plus 1 equals log to the base 2 of 5. How do I solve for x? Subtract 1 and then take the square root. So it's going to be log to the base 2 of 5 minus 1. Then I take the square root. That's going to be plus or minus. Question. Does that make sense? Can I take the square root of log to the base 2 of 5 and subtract 1? Would that work in a square root? In other words, is this number positive? Is it 0 or positive? How would you know? Tell me what you know about this guy. Let's see how much our intuition is working here. Log to the base 2 of 5. What do you know about that number? Give me some approximation for it. Yeah?
It's going to be bigger than 2 because 2 squared is 4.
It's going to be bigger than 2. We know that log to the base 2 of 4 is 2. And we also know that log to the base 2 of 5 is bigger than log to the base 2 of 4. Now there are tons of ways you can figure that out. One is from just the definition of what a logarithm is. Another is from the graph. Know that the log graph is increasing, which means if 4, whatever answer that gives, if 5 is more to the right, it will give a bigger answer. So we know that this part here is greater than, this part here is actually greater than 2, because log to the base 2 of 4 is 2. And so this expression here is definitely going to be positive, because it will be bigger than 1. It will be bigger than 2 minus 1. So it actually makes sense. These are things you guys should also be prepared to figure out. Just really get an intuition for what the logarithm actually means. You want to think in terms of exponentials. So the 5 is bigger than a 4, so log of that relationship is going to hold. And so this actually makes sense. This has a solution, and these are them. Now, solve. Ideas.
Can you add 6 on both sides and then bring down 2x and then x on
That's 6.
right, and then like bring the 2x and the x to be that's right.
Huh?
That's right.
Yeah, that's not right.
Yeah.
Like, why?
Just because you can't cancel. I mean, I don't know. I think you're supposed to cancel before you do that. I don't know.
Yeah, but why did you do this in the first place?
I just thought that was. I don't know.
I mean, I guess you want that because if you like L on both sides, 0 will be up to the L and 0 and the other prime. Like that.
Not really, because you wouldn't ln both sides. But I first want to deal with why is this wrong?
Because quadratic equation.
Well, no, I mean, when are we allowed to take a power and bring it down in front? When is that allowed? Right, you need a log, right? So we had a rule, it's very important. So remember what the rule is. If I have log to the base a of something to a power, I'm allowed to bring that power down, right? That is valid. There is no such rule for exponentials, right? Here I don't have a logarithm, so I can't actually do this. So this would actually be wrong, right? And a big hint as to why it probably shouldn't be what you would want to do is because you said yourself, when you answered the other questions and you were right, and you knew you were right. When you did this, you kind of You kind of felt uneasy about like, I don't really know why I did that. That's a problem. Never do anything you don't know why you're doing it. Because chances are, it's going to be wrong. Right? So, when you said, I don't really feel good about this. Can I actually do that? What you would do is go to the rules. When am I allowed to move a power down in front? Oh, there has to be an LOG or an LN somewhere. Is there an LOG or an LN somewhere? No, meaning this is not allowed. Okay, so that we can't actually do that. So if we did this, what's going on?
Just add log on both sides now. Can you do that?
Okay, so let's say I LN both sides. What's going to happen? Come again? What becomes 2x? So it becomes 2x minus x.
Combine like terms.
What did you just do here?
No, I was thinking like LN, the first one and the second one, but that didn't work.
How can you do that though? When you say log both sides, it means you take the entire side and you plug it into a logarithm, right? You can't just log individually.
Yeah.
Which means what you just actually did was you distributed the logarithm to two separate things. Not a rule. That is also not legal. Cannot do that. No rule allows us to do that. Yeah.
Divide.
Divide by?
It's like if you have e and you put 2x divided by e to the x.
Divide this by 2x.
Yeah, like put e to 2x over e to the x after you add 6 to the other side.
Oh, okay, so we want to add 6 to the other side. And then?
There isn't there a rule that says you can divide. So e to the 2x divided by.
No, division is when you have a subtraction in the power,
Yeah.
right? Subtraction here means division. Subtraction there does not. Doesn't fit the rule. Ideas? Do you have an idea? No idea? Huh?
So what's your idea?
It's my idea. We're bringing it back. This is really old school. This is a lesson that I told you guys a long time ago. Remember when we were doing that? What was the idea? Just because something looks scary doesn't mean that you should treat it. I don't even remember right now what that was. Something like this, right? Right, you kind of want to think of factor. It's an equation equal to 0. Go to basics. How do I solve that? Factor. Now you know I want to factor, right? So moving the 6 to the other side, that would never be my first step because that's not how I solve something equal to 0. To solve an equation equal to 0, I factor one side and then set each factor equal to 0. Now the question is, how do I factor that? Huh?
We could just say,
You see something?
is it
What?
like e minus 3 times e, well, e to the x minus 3 times e to the x minus 2, but plus 2, something like that.
How did you get that?
You're doing, this is like quadratic, right?
It's
So-
a quadratic. This, what I just wrote down, is a quadratic equation. Now, that brings us back to another lesson I told you guys about. Knowing the forms and the formulas so well that you see it everywhere. This is e to the x squared minus e to the x minus 6. What is the form of this thing that I'm looking at? It's actually a quadratic. What if I had, instead of e to the x, what if I had written y, right, or some other variable? That's what I'm looking at right now. It's a quadratic equation. One, know the rules. First of all, they tell you when you're doing something illegal. Whenever you feel like, oh, can I move the 2 down? Is there a rule? Nope, I guess that's wrong. right? They will tell you when you're going to make a misstep, but they also kind of tell you how you want to approach a problem, right? First of all, you should know an overall strategy. Okay, if I want to solve an equation equal to 0, what do? I factor one side, set each factor equal to 0, as long as the factors are linear, and then I move on. So once you think that, okay, I want to factor, what do? Look for common terms. Okay, no, can't do that. If there are 3 terms, what do you think? Well, something like the AC method. You start to think of it as if maybe it's a quadratic or something like that. And yeah, once you see that one power is double the other power, and that variable doesn't show up in the third thing, it's quadratic, right? So it doesn't have to be like x squared plus 3x plus 2 equals 0. It could be x to the 4th plus 3x squared plus 2 equals 0. You can treat that like a quadratic. X to the 10th plus 3x to the 5th plus 2 equals 0. That's also quadratic, right? And I can throw anything else in here I want. ln of x to the 6th plus 3 ln of x cubed plus 2 equals 0. That is also a quadratic. I will treat them all the same way. They're all the same form. They're the same kind of animal. They are quadratics, right? So you really want to know these formulas so well that you kind of see them everywhere. Every time you're trying to think of what do I do now, the answer is always, there's a rule somewhere that is a template for the thing you're looking at. Figure out which rule it is. There are 3 terms. How many things do I know with 3 terms? Quadratics, that's the most important and common thing that we deal with in 3 terms. So if you have 3 terms, you're probably going to want to check, is it a quadratic? And you can tell by how the powers relate to each other. Make sure that one power is double another. So now, realizing that it's a quadratic, you can factor. Well, if I had the y squared minus y minus 6, how would I have solved that? Well, I would try to factor. Now, if factor doesn't work, what could I have done? Quadratic formula, of course. But this one, I think, factors 3 and 2. And you put a minus here and a plus here, and that would actually factor it. So you essentially do exactly the same thing here. Just think of the e to the x as your variable. It's going to be e to the x minus 3 times e to the x plus 2. That is how we'd approach it. It's a quadratic equation. Okay, now that I got this far, what do I do next?
Equal 1 equals 0.
You set each equal to 0. That's the strategy. I want to solve an equation equal to 0. Factor one side. Done. Next thing, set each factor equal to 0. So this means my e to the x is equal to 3, or my e to the x is equal to minus 2. What does this mean? X equals ln 3, right? Log both sides. Right? I just ln, kill that, x. X equals? Huh?
It's undefined.
Right, there's no solution here. Right. So that does not give us an answer. We only have one answer here. Right? Because e to the x is never going to be 2. I know what the graph of that looks like, right? Minus 2 is down here. The graph never touches minus 2. I also know that I can't actually log negative 2, because if I look at the ln graph, that looks like this. I cannot plug in negative 2 into that graph. It's not going to work, so there's no solution here. So x equals ln of 3 is the only solution to this equation. Remember your lessons, grasshoppers. That's one of the challenging things, that's one of the challenging things with mathematics, is that once you learn something, it's always going to be applicable. You can never forget it, right? So the lessons that I was telling you on day 1, they still apply now. They will apply on the last day of class. They'll apply in the next class that you go into, right? So the idea of having a strategy, knowing the rules well enough to think of them as templates, knowing how to factor some random thing, like all the lessons that we've learned before, they are still valid. They are always valid. Just because something looks scary doesn't mean it actually is scary.
Bless you.
So we just have to realize and this is true up to like Calc 2, Calc 3. I mean, life gets complicated, but in this class, for sure, something looks complicated, it looks difficult. There's really a simple reason, a simple explanation for working it out. And there's just some rule that you need to think of that fits the situation that you're looking at. Okay. What do I do? Combine. So last time we ended the class where we did an example where we combined, we had these logs spread out and we combined them into one big log. And then we had another example where we had this one big log and then we split it up into a lot of little logs. And then I mentioned, oh, when it comes to solving equations, combining logarithms is going to be very convenient. When it comes to doing calculus, so you have to worry about this next semester, expanding logs is going to be very convenient. But here, I want to solve an equation, so I'm going to think of combining logs. How can I combine this one? So it's log to the base 4 of the product. Right? The log of a product is the sum of the logs. I can do the same thing here. Now what? I want to solve for x, right? Which is stuck inside of the logs. If only there was a way for me to get inside the logarithm. Right? How do I get inside that logarithm? If I want to get inside and get to this x, how do I get rid of the logarithm up there? Ideas? Yeah?
Is it possible to subtract the log and then do like division rule when you have like two logs the same base? You can like divide the inside?
Sure. You'd end up at the same place though, so I probably wouldn't want to do that. But that wouldn't be illegal. There's an easier way. Because if you do that, eventually you're going to have to deal with this division, right? You're going to eventually have to deal with the 3x plus 2 divided by 5 times 2x minus 3, which that in and of itself isn't going to be fun. So I'm not going to want to introduce a division. But those logs are pretty annoying. That's your cue. Whenever you think, oh, that log is pretty annoying, like the next step is always clear once you have that thought. How do I get rid of the logarithm? With an exponential. What exponential? 4, because it's a log base 4. And raise both sides to the base 4. That cancels that. So it turns out that 3 times x plus 2 equals 5 times 2x minus 3. So that's 3x plus 6 is equal to 10x minus 15. Let's finish over here. So I can move the 15 over there, and that would be what, 21? And then I can move the 3x over here, and that would be 7x. So we get x equals 3. Now, just like when it comes to those problems where we want to square both sides or something like that, you tend to always want to check your answer when you have a logarithm, because or an exponential, because there are points in here, not even exponentials, but the logarithm is very finicky. The domain isn't all real numbers. You have to make sure that what's inside is not negative. So you plug in a 3, not negative, so we're cool. You plug in a 3 here, not negative, so we're cool. Do these things actually give you the same number? Well, I plug in a 3 here, that's log 5. Log to the base 4 of 5 plus log to the base 4 of 3. Notice that I can combine those. That would be log to the base 4 of 15. If I come over here, log to the base 4 of 5. If I plug in a 3 here, I would have log to the base 4 of 3. I can combine those, so both sides will give me log to the base 4 of 15. That actually works, so that's your answer. Remember your lessons, grasshoppers. Even the ones from the beginning of this class where I literally told you, whenever a log is kind of annoying and you want to get rid of it, use an exponential. And I was here and I'm like, that log's kind of annoying. What do you think, guys? I don't know. Everyone, don't freak out. I think you guys are freaking out. What I'm writing on the board, it looks scary, and I think you guys are psyching yourselves out. It's not understand. Oh, there's a log here. I know how to deal with those. I know all the rules, and I know how to get rid of them if I want to. Right? Just raise both sides to the same base, and that kills the log. If I don't like an exponential, I log both sides to the same base. That kills the exponential. That's always going to be a thing. Okay, what about this one? Combine, right? Very convenient when solving equations. You want to get all these logs from spreading out. Remember, when you're solving an equation, you want to consolidate things. You want to combine all the x's. You want to combine all the numbers. So you start with this combining idea. So that would be the first step here. Now what?
Can you get rid of that log like we did the other one?
Yeah, get rid of the log. How?
Just make it-
Raise both sides to the 2. That's going to die. We're going to have x times x minus 3. And over here we have 2 squared. Now what? How do I do that? Huh? Right, bring everything to one side so it equals 0. So if it's not a linear equation, that is a general strategy. Bring everything to one side, set it equal to 0, factor, and solve for x. Set each factor equal to 0. Does this actually factor?
Yeah.
4 and 1. Minus 4 and plus 1. Seems to work. So this means our x is either 4 or our x equals minus 1. Now we need to check this. Does 4 work? Log to the base 2 of 4 is 2.
Right.
If I plug in a 4 here, I get 4 minus 2, which is 1. Log to the base 2 of 1 is 0. So I get 2 plus 0 is 2. So that one actually checks out. What about minus 1? X equals minus 1. Or I can't even do it. I can't even plug it in the first place. So this one is rejected. You can't log minus 1. So you get rejected. Like, why is that so funny? So x equals 4, the solution to that equation. Right, so now you guys know how to solve a whole new class of equations, exponential and log equations. Basically, all the old strategies of solving equations still apply. The only difference is now you know if I have a bunch of logs scattered all over the place, I know how to combine them. If I want to get rid of a log, I use an exponential. If I want to get rid of an exponential, I use a log. So you just add those few lessons to all the lessons I told you before, and just remember all of them all the time, forever. Yeah. And then that's it. That's all you have to do. Just you think of all the rules all the time, forever. That's how you do well in math. It gets easier. You just have to get used to it.
Stick my head down.
Now, I think I still want to spend some time on these guys. Let's show you how to deal with the graphs. So I'm also going to ask you guys to graph these things. Graph A. C. Actually, we'll do one of them. I think I wanted a 2 here. So get the graphs of logarithms and exponentials. So, again, like always, the lessons of the past will apply. So graphing these guys is going to be very familiar to graphing, say, a quadratic equation. So we know when graphing a quadratic equation, we already have the shape in our minds of what it's going to look like. It's going to look like this or it's going to look like that. In the same way, when you want to graph exponentials or logarithms, you already have a shape in your mind. You just need to know what points to draw that shape through. Right, so think similar to a quadratic. We automatically know that assuming our a is greater than 1, if I have log to the base a of x, the shape looks like this. And if I have a to the x, the shape looks like that. Yes, I know they have asymptotes, but I have a general shape in mind for what it's going to look like. And I know if I were to put a negative in front of this just flips upside down. Same thing with that guy. If I were to make a negative on the x, it will flip it that way. This guy also would flip it that way. So we have the transformations and we have the basic shapes in our heads. So now we just want to know what are the points that I want to draw the respective shapes through. And so we are going to find some convenient points here. So when it comes to graphing, what are convenient points? The intercepts, right? That's same thing with quadratics. You want to find the intercepts. So say I wanted to find the x-intercept. How do I find the x-intercept? Set y equals 0, solve for x. Always how you find the x-intercept. This gives us a log equation, which now we're experts at solving. So how do I solve that?
Get rid of the log of 3.
So x equals 10 is the x-intercept. Is there a y-intercept? None, right? Because I would plug in x equals 0, but I can't actually plug in x equals 0. In fact, logs, remember, they have an asymptote, right? There is a line that these logs approach, but they can never actually touch. And that happens precisely when what's inside the log is 0. Notice here that x equals 1 makes this 0. What that tells you is this is the asymptote. So we have these convenient points. I couldn't get 2 of them, so I want to know something else about this graph. And a good thing to know would be where the asymptotes are. Is there a line that I cannot touch? Turns out that x equals 1 is that line. So now I'm going to grab this, say still like that thing. There's this dude on MIT OpenCourseware, I forgot his name, but he knows how to draw dotted lines.
Oh my gosh,
really quickly.
yes!
You know what? You
Yes!
and like,
And like
how does he
super
do that?
strict, yeah.
Yeah, I'm gonna figure out how he does that, and I'm gonna start doing it every time I'm drawing and ask him. Yeah, it's really cool.
Sounds like a
Okay.
machine gun.
Sounds like a machine gun, yeah. It's crazy. Me, I'm here like my primitive self, yeah. But one day, okay, so let's get back on track here. I know that we passed through 10. I'm just gonna pick a random point here and write 10. I also know that I look like a logarithm. Now notice that this logarithm, it's a positive sign in front, right? Which means the shape should look just like this. So that's where I'm gonna draw. Let's not necessarily put it to scale here, let's put it a little closer. So I just know I'm gonna draw that shape through that point, and then it's gonna go there. And that's it, that's the graph. So the idea is, that in principle, we graph it pretty much the same way that we'll graph quadratics. We have a shape in our mind, we just want to know where we're going to draw this shape on the page. And we use things like the X and Y intercepts, as well as the asymptotes that these graphs have, to figure that out. So that was the first one. Okay. You guys draw the second and third one. You guys. 6 minutes. And then you're going to tell me how to do it. And then we're going to do it. In next class, we're going to start trigonometry. I'm so excited. It'll be so fun. Quizzes after Thanksgiving. Because it's going to be like, you guys are going to forget everything. I want you guys to be studying.
Wait, so we'll have a quiz that Monday and then the test that Thursday?
Yes.
Okay.
Our test is like the last day of class or something. Everything since the first test. Yeah. The second test is a pre-final to half the final. So the final is going to be like test 1 and test 2, like matched together.
Wait, really? That's so sweet.
Basically, yeah.
Test 1 and test 2.
Yes.
Now they have to write my study.
So that's what it's going to be. Yeah. It's going to have somewhere between 20 to 25 problems.
Okay.
And it's like roughly half of them is stuff from test 1, half of them is stuff from test 2. And it's the final is going to be 2 hours long, 2 hours and 2 minutes. Anyway, do this. Focus on this now. So do B and C. You have like 5 minutes left. minute left. I'm coming out of doing this one.
Try to make it y equals 1.
So you find the x-intercepts. So that y equals 0. About that.
Subtract 2 on both sides.
Yeah, or maybe add the log on both sides of the master. Raise to 2. So this gives us 1 minus x is equal to 4.
No,
Sorry.
-3.
X is equal to -3. Is there a y-intercept?
No.
Well, how do you find y-intercept? Is that x equals 0? Is that possible? That's totally fine. Log of that gives us the log of 1. Log of 1 is 0. So y equals 2 is the y-intercept. So we have 2 intercepts here.
How come that 2 is not negative? Because you had it on the other side. So why-
What 2 is not negative?
That, when you raised it to the second power, you said.
Oh, I didn't move the 2. I moved the log.
Oh.
Because the log was
right.
negative, so I
Yeah.
decided to
Okay.
move that
Oh,
instead.
okay.
So, we have, that's our x, that's our y, and we actually know that if we're 1 minus x equals 0, that would mean x equals 1, right? So that would mean that this is an asymptote. I also know that -3 is a point, the x-intercept, and 2 is the y-intercept. How does this graph look? Like that, right? So notice here, the log is negative, which means the picture I should have in my head is this one, but flipped upside down. So it should be looking like that. So, and it doesn't touch the 1, because right there we get log of 0, which is undefined. Of course, it also makes sense because I have the x itself is also negative, which tells me I should flip on this side, because the x here is negative, and then I shifted it. So yeah, that's what that graph looks like. An upside down log graph that's flipped over, and I found the intercepts. What about the last one? Well, C. we do here? Huh?
Set y to 0.
Okay, so for x-intercept, set y equals 0. Which means e to the x plus 1 equals 1, which means, how do I solve for x? Log both sides. ln of 1 is 0, this is just giving me x plus 1 because the e and the ln kill each other, so I get my x equals minus 1 is the x-intercept. Do I have y-intercept? For the y-intercept, so this is going to be y equals 1 minus e to the 1, right? Which is a number. So, remember what e is? E is 2.71 something, so this is like 1 minus 2.7-ish. So it's definitely a negative number.
Wait, you ln that, right? To cancel out the e.
Yes, I ln both sides.
Okay.
So I ln of 1 and ln of that side. And, okay, so what does this actually look like? Can I fit it in here? So the y-intercept is going to be negative and the x-intercept is going to be negative, so it'll be closer to here. So notice what this looks like. Well, it's like I took an e to the x. Yes, I shifted horizontally, but I don't have to worry about that for now. The important features are I made it negative, which means I'm going to look at the e to the x graph and it's going to flip upside down. And then I add 1, so I'm going to shift that up. That means the asymptote is going to be at 1. And then I have my intercepts where they are both negative, so it's going to look like it's supposed to cut through this. This point here, whatever that point is, I'm just going to call that 1 minus e. This point here is going to be minus 1. That's my asymptote over there. So D, want to graph the inverse of part A, which was y equals log to the base 3 of x minus 1. Yeah?
How do you know your asymptote was like that?
Oh, because I know y equals e to the x. Looks like this. So if I have y equals minus e to the x, it's going to flip upside down. So remember, for the exponential, the asymptote is actually at level 0. It's at y equals 0. Now if I flip it upside down, it stays at y equals 0. But then finally, I took that and then I added 1 to it, which is this 1 here. So that shifts everyone up by 1. So namely, the asymptote itself gets shifted up by 1. And so the graph will look like that. But then with the x, I also shifted it, so then these two intercepts shift over to over there. So yeah, the asymptotes for the exponential, if you look at it's going to be given by the constant essentially. So if you have y equals a times b raised to the x plus c, y equals c is the asymptote. Because the asymptote starts off at 0 for an exponential, and the plus c, when you add a constant, it shifts it up or down. Now, there are a couple ways you could graph the inverse of that. First thing you could do is you could graph that, which we already did, and you can reflect it in the line y equals x, and just do the mirror image. But since I already erased that graph, we have to start from scratch. So probably what we would do is find the inverse and then sketch that. How would I do that? How would I find the inverse of this function?
Switch X and Y.
Switch x and y, and I want to now solve for y. This is going to be x plus 2 is equal to log to the base 3 of y minus 1. How do I solve for y? Base 3, that's how you get rid of a log. So this is 3 to the x plus 2 power is going to be equal to y minus 1. So my y is going to be equal to 3 to the x plus 2 plus 1. So again, that tells me that the asymptote is shifted up 1. And what I can do is do the x-intercepts, set y equals 0, solve for x. This would mean minus 1 is equal to 3x plus 1. That of course has no solution. Exponentials are never negative. And I can do the y-intercept. And that means I would plug in x equals 0. So this is 3 to the 2 plus 1. So that's y equals 10. And that makes total sense because in the other graph our x-intercept was 10 and we had no y-intercept. The inverse is going to be the opposite. It's not going to have any x-intercept and the y-intercept should be 10. So what is this going to look like? Well,
I have a question.
yes.
How did you get it from 3x plus 2 to 3x plus 1? I mean 3 to the x plus 1. Instead of 3 to the x plus 2.
That should be it.
Oh. But then there's still no solution.
There still won't be a solution because it's still an exponential, but that should be it too. Yeah. And here, yes, I did it too, which makes perfect sense when you think about the other guy. So the other guy, you would have noticed he looked like this, right? Going through 10 over there. So that makes sense if you can actually put the y equals x and see that, oh, the other guy was over here, so that's what happened. So that's that graph. So you should know how to graph exponentials and logs relatively quickly. The idea is find the points of interest and their asymptotes, and then you just have a shape in your head that you're going to be sketching. So know the generic shapes. We will stop there. So yeah, test 2 is the 5th, and our final I think is the 16th. So 11 days after test 2.